Alright, this is the introduction for the lab on equipotential surfaces, and something that we know is that if we have a positive point charge, that the electric field is going to go radially away from it, kind of as such. And if we had a negative point charge, then the lines of electric field are going to be radially towards it. So I could draw this guy right there, and it's going to go kind of inwards as such. What we can then do is we can then say, I know that lines of equipotential are going to be surrounding these guys, and it's kind of like having lines of constant altitude around a mountain of a map. So this might be 10 volts, this might be 20 volts, and we're going to have a circle around these guys kind of as such. This might be negative 10 volts, and then this guy right here, and this guy right here. All we're going to do is we're going to map these out for a couple of different charge configurations. You can kind of find what to expect in your book. So you can click on this link just right there, and we can go ahead and check some various boxes here. What we're going to do is we're going to sketch the lines of electric field. So you're going to go ahead and plop a positive charge on there and just answer some very simple questions. We can then measure the equipotential in a couple different places, and we can even measure the equipotential as a function of distance. So let's go ahead and take a look at what the simulation looks like. So we can go ahead and we can put this guy just right there, and I have checked some boxes here, and we can go ahead and find what the voltage is. If you actually click the line, you can go ahead and mark some lines right here, kind of as such. And for the distance, well, you can go ahead and use this tape measure just right here. So pretty straightforward. What we can then do is you can go ahead and graph these guys. And what do we expect? Well, we kind of expect the voltage to die off like 1 over r squared. So what we can do is we can say V should be equal to K times Q divided by R. Your graph should correspondingly show that. It should show something that dies off like 1 over r, or an inverse relationship, if you will. Please do note the electric field is always going to be perpendicular to lines of constant potential. Then what you can do is you can do this for a couple different configurations. So you just go ahead and you stick a negative charge in there. I'm not going to show you that because it's pretty straightforward. And then you're going to go ahead and put 2 positive charges, 2 negative charges, and then you're going to do what's called a dipole, which is going to be a positive charge and a negative charge. And all you're going to do is map out lines of constant potential and sketch in where the electric field lines should be for that. Again, the book is going to give you a hint for what you should be looking at. Last but not least, I have you go ahead and do a line of positive charge and a line of negative charge and identify where the electric field ought to be and the lines of constant potential. In the real world, we're actually going to call that in a couple of chapters. We're going to call that a capacitor. And this is going to be super, super, super important. There we go. Now I fixed it.